Alright, so this is about the cleanest look at this that I think I can present of transcendental function, logarithms, being useful and cooperative with dimensional analysis, right? So recall that for a vector with two components, a and u, where a is the scalar magnitude and u is the unit, log base au of bv, where bv is another vector of scalar magnitude b and unit v, log base a of b is exactly equal to log base u of v, right? So the log of base number component of au of number component bv is the same as log base unit of au of unit bv, right? So it makes sense to take logarithms whose base is a bare unit, and when you do so, the argument is also a bare unit. Or put another way, the unit v of vector bv is the unit u raised to the log base a of b power, right? So the Koch snowflake rule is we've got these three lines and they get converted into four lines of the same length, right? But it's not really lines anymore. It doesn't, it's because see how it kind of bent up into us in another direction? So it's not a straight line anymore, right? So 3u, so these are linear units right here, turns into 4 u to the log base 3 of 4. Right, so they're not linear units anymore. Right, so when you apply it infinitely, blah, blah, this means that the Koch snowflake is not a line, which is the correct result. Right, it has a fractal dimension. Now, for squares, we can do something very, very similar to this, just squares. You know, nothing interesting, right? So we can turn these three lines into a square with 9 components, right? So this is a linear unit, it's that, but when we get 9 of them out of this, their unit is that linear unit raised to log base 3 of 9, which is 2. So it's square units, right? So 3 length units become 9 square units, right? So there you go. Like, not only is the account that you can't handle dimensional analysis with logarithms nonsense, I just showed you how you can do it brilliantly. How you can actually use logarithms to correctly figure out what the units on your result should be. Right? What the unit on the numerical result from a logarithm should look like. It's not complicated. It's not this complicated. I don't understand what the confusion is. But yeah, like this is it. This is how it works. So you can use, this is strictly numbers, but because how it works, if you were to take the log whose base is a vector and its argument is a vector, you can separate out the log base number portion of the number portion. You can isolate that, and that is exactly the same as the log base unit portion of the other unit. And that relates this unit to this unit in the same way. So the unit of BV is related to the unit of AU in the same exact way that the number of AU relates to the number of BV. That's This is... I don't know how this is not something that isn't taught to everyone, but it is a basic identity that you should know. Because if... I feel like if you don't understand this, what the fuck are you ever going to do with a logarithm? This is the only thing that logarithms are good for. Because, right, what it is we're taking something like this, and the logarithm is determining the dimensionality of it, right? So this old guy that I've been showing, right? So you've got a to the third is this, and we can call that b. So log base a of b is 3. It's the exponent, the number of dimensions, right? So, like, you know, a unit of length might be a meter. A unit of area will be a meter squared. And a unit of volume would be a meter cubed. Right? This is the number of dimensions that this operates in. It's not magic. And the logarithm, what it does is it gives you that out. That is its output. Logarithms are most useful for determining what your units should be, what your dimensions should be when you're doing dimensional analysis. This is a tool for figuring out your units. I don't understand what the fuck. I'm like, oh, you can't use logarithms with dimensional analysis. Excuse me? You clearly don't know what you're talking about if that's what you think. You're clearly completely incompetent.